Hey everybody, in this video we're going to be talking about DGP, which stands for Decentralized Governance Protocol, and its use on Qtum, but more specifically we're actually going to go through a brief tutorial showing you how it works on a Qtum reg test environment. So we're actually going to take that step-by-step process so you can see how it works, as well as if you would like to follow along, I'm going to give you all the commands that you need to do so. For now I'm just going to give you a brief introduction to what DGP is, so you have more of an understanding. However, if you want to go deeper into it, there's a couple of articles online, including one that I wrote myself, which I will link in the Medium article where this video will be posted. So DGP runs on top of a smart contract. Essentially, it is a method through which you can propose a change of consensus value. Consensus value being the values through which the blockchain is actually running. This includes block size, minimum gas price, all of those core values that the blockchain needs to run properly and that every node and client code will be using. However, if you ever want to change these values, the developers actually need to push a hard fork, and as many of you might know, a hard fork is very tedious. It's a big deal to do a hard fork, and you don't really want to do them very often unless it's absolutely necessary. For example, an upcoming hard fork for Qtum would be when they introduce x86 to the system. So you don't really want to push hard forks. So a DGP contract can help with that. Once it is published, you can use the smart contract where you have a set of admins and governance parties that can vote for a proposal to change a value. So if an administrator decides that it would benefit the chain to change the minimum gas price, then they can push that proposal through the Decentralized Governance Protocol contract, and then everybody that is in that system, all the admins and governance parties that are in the system of the DGP, can vote for it, and if the vote is passed, then that value is actually changed seamlessly without the need of any forks. The blockchain will now run with the new value instead of the old value, whereas all the previous blocks will have the old value. Every block moving past the DGP vote, once it's passed, will actually have the new value. Again, if you want to understand more about how that works, I recommend looking into some of these articles, but that is in brief what DGP is and what it's supposed to do. Alright, so what we'll do now is actually set up the environment that we need to show you how DGP works. So what we're going to do is we're going to set up a local reg test environment to run our own little local Qtum blockchain, and then we're going to interact with one of the DGP smart contracts. Just so you know what I mean, what a DGP smart contract is, if you would like to look into it, I'm going to link this on the article. Here there's the GitHub page that shows the Qtum DGP contracts. So there's, like I said, there's 4 main ones that are running that take control of the block gas limit, the block size, the gas schedule, and the minimum gas price. These ones are the actual value contracts, which we'll get into later. But each of them has one DGP smart contract, like this one, that is controlling the value in essence. So if you want to take a look at the smart contract to know exactly what it's doing and how it works, you can go ahead and go to this page, which I will link, and here you will see all the different things you can do. So adding address proposals, this includes adding admins, adding governance parties, and adding the value smart contract address for when you actually want to change a consensus value. Again, I will go into a little bit more detail into what that means later, but you can look at the article that I mentioned before to get more information on what that actually means. Removing, these are all management things, but this is the smart contract that is actually running. So there's 4 of these currently running on Qtum, each of them controlling the aforementioned values that I talked about. All right, so what you're going to want to do first is set up a reg test environment. There's various ways to do this. The easiest that I think is just using the Docker. One of them that you can find is on qmix.blockchainspaceman.com. You go to the little question mark here and just copy and paste this command right here. Open up a fresh command line. You just paste that in. It will download everything that you need, and then it will run. Just check that it's there. And now you have a Qtum reg test environment. I would recommend going to Qtum Book. That's the developer guide for Qtum. To look at more of the commands that you can do. This is a really cool little thing. but once you're running the CLI, I accidentally put a space. You can see all of the different things that you can actually do. So I'm running the local blockchain, and here are all the different commands you can do to interact with your little local blockchain. I've released a couple of videos for different reasons, one of them being understanding raw transactions. Take a look at that one if you're interested. I go into a lot more details into all the different things you can do with this CLI. But the first thing you're going to want to do is generate 600 blocks just to make sure that you have everything that you need to do what we're going to do. So that's what you need to do just to set up the environment, and now we're going to go ahead and start interacting with the DGP. What we're going to do is actually change the minimum gas price needed for a transaction. So now we just need to do that. All right, so now that we have the environment set up, the first thing that we're going to want to do is setting up the addresses that we're going to use for admins and governance parties. So what I mean by admins and governance parties is in DGP smart contract, it has a list of admins and a list of governance parties that are the ones in charge of voting for proposal changes. The admins have a little bit more administrative power per se. They are in charge of the whole management of the DGP. So what this means is that an admin can propose adding another admin, they can propose removing an admin, they can propose adding a governance party, removing a governance party, and they're also the ones who make the proposals to set the amount of votes required for any proposal to pass. For any management proposal, that being adding, removing administrators or governance parties, or changing the number of votes, only admins can vote for those. Whereas governance parties, they can vote for the change of value proposals. That's the only thing they can do. Admins can also vote for change of value proposals. So ultimately, admins are in charge of everything that has to do with managing the contract, and they are also in charge of voting, as well as the governance parties, of voting to either pass or not pass a change of value proposal. All right, so we're going to use 5. We're going to do 3 admins and 2 governance parties. So what you're going to do is get new addresses. We're just going to do this 5 times. And I'm just going to set some local variables. This will make it a lot easier for when we're doing the later stages of this demonstration. Right, so once you have your 5 addresses ready, we're going to go ahead and initiate one of the DGP smart contracts. And in fact, if you want to see these DGP smart contracts, when you start your environment, you can do list contracts, and you'll see that there's already some smart contracts running. All of these are DGP smart contracts that are created at Genesis, essentially, and these were actually created at Qtum's Genesis. So these are DGP smart contracts that are currently running on Qtum, and if the administrators would like to change one of the values that these are controlling, they would do so through the DGP smart contract rather than creating a hard fork. Right, so what we're going to do now is we're going to go ahead and manipulate the minimum gas value, and this is going to be the set of commands. Again, I will post this in the article, but these are going to be the set of commands that we will be using, and we are going to be manipulating smart contract 000082, which you can see right here. So this smart contract right here, that's the DGP smart contract that is in charge of the minimum gas value. All right, so let's go ahead and do that. All right, so what we're going to be using is those commands that I showed you Just to give you a little bit more context on them, and I will be explaining them as we go along. We're going to be sending to contract, essentially to the one contract the entire time, and we're going to be specifying certain functions. However, these functions are obviously in hex code. If you want to know what they are specifically, I will be explaining it, but I will also include this in the article where the video will be posted, and here you will be able to see what each of these functions from hex to what they actually are in the DGP smart contract that I showed you. So these are all the different functions you can do in the contract, and these are the functions translated into hex code, so you can see what they actually mean. And so if you decide to play around with it, you can use different functions as well. And so we're going to be doing that. So what we need to do first is set our initial admin. Right now there's 0 admins in the smart contract. So we're going to send to contract via the first admin in order to be set as the initial admin, and it will do that through this function right here. And that will be setting our initial admin. To do that, first we need to make sure that our admin has a UTXO. So what you're going to want to do is send to address, and you can just use $admin1 since we've set up our local variables. And just send it one quantum. You don't really need to send anything else. And then generate one block. And if you just want to make sure that it has that one that UTXO that you need, you can use list unspent. So list unspent. And I actually forgot exactly how to do it. So you can type in help before any of the commands, and it'll tell you what you need for each of them. Yeah, I forgot. So there's a special context to what you need to do it. All right. So what we do here is just, and we can just use our local variable again. 1, and then it needs backslash first. And it needs to be backslash on this one, sorry. All right. What did I do wrong? Oh, yeah, you have to specify the minimum and the maximum, so we'll do, I think the minimum is, what is the minimum? Minimum is 1. So let's just do 1, and 2, 3, 4, 5, 6, 7. All right, and we can see here that we have that UTXO that we need. All right, so now we know that our first admin has the UTXO necessary. We can just go copy and paste this command. So what this is sent to contract, sent to that DGP contract controlling the minimum gas value. We're setting our initial, we're saying whoever sends this is the initial admin if there isn't already one. Since we just set up this environment, there won't be one. And this is just the gas specifications. So the max gas value and the gas price. And we can just copy and paste this. Excellent, press shift. Just make sure that you have the QCLI command as well. And don't forget to generate one. Should have it up here. Anytime you do one of these commands, you want to generate that one block to make sure that the transaction is actually posted. All right, so now we have admin1 set up as the initial administrator. And what we're going to do now is, normally you would need to vote, but since this is the initial stage of this environment, and the DGP contract is fresh and it has no admins, there's only one admin, and currently the votes needed for something to pass is only 0. And whenever an admin makes a proposal, it instantly votes for it. So in this case, there was no votes needed, and in the case coming forward, since the admin one that is creating those proposals is instantly voting for them, the coming proposals will be passed instantly. So our next proposal is going to be to add admin 2 to the DGP smart contract. Here I can explain that management still is 0, so it will just instantly vote for it as well. All right, so we're sending again here to the DGP smart contract in charge of the minimum gas value. This is the function to add an address. Here we're going to put the address. This is the value that you would be passing if it were a function in normal code. We're going to replace this with the hex code. It has to be the hex code, not the quantum address, the hex address. of the admin2. And again, these are just gas parameters. And the one sending to this contract is going to be admin1. So go ahead and copy this right here. And again, and before you do that, actually I'm just going to do this, it's going to fail. I want to do get hex address admin2. All right, so we have the hex address right here. We can go back to this one, and you just want to go to where it says replace with admin2 hex. Delete all of that. Make sure you don't delete too much, and then just replace it with a hex address. All right, so now that you have that, press enter, and again, generate one. And now admin2 has been added to the DGP smart contract. So now we have two admins. And what we're going to do next is we're going to change the number of votes needed, because right now it's being passed instantly, and obviously we don't want that. So we're setting up this environment to be semi-robust. Obviously we're only using 5 different addresses in this case. What we're going to do now is we're actually going to make a proposal to require 2 admin votes in order for any management proposal to be passed. So that's what we're going to do. All right, so let's go ahead and get that command. So we've generated one block, all right, so that transaction has been issued. And now we're going to require 2 votes, like I'm saying here. Let me add a space to make it more readable. All right, so again, send to contract. We're sending to that same contract that we've been sending to. Again, look at the change in numbers here. That's just a different function. This function is saying, all right, we're going to change the number of admin votes required to do management proposals. And here you can see that there's a 2 at the end. That's the actual value we're passing forward, saying we need 2 admin votes. And again, gas values, and the address sending it is going to be from admin1. All right, so in this case, we don't actually need to change anything since there's no other hex code or hex addresses that we need to add. So let's just make sure to not copy too much. Let's copy that. Just doing this so it's easier to get to it later. And paste that. And we're going to, since admin1 should already have UTXOs, it will pass. And again, we want to generate one, and that has been posted. So now, in order for anything that we want to do management-wise to the DGP smart contract, we're going to need 2 admins to vote for it. All right, so when the first admin is creating the proposal, that's 1 vote, because by creating the proposal, that admin is also voting for it. We will now actually need the second administrator that we added to vote for that proposal in order for it to pass. So now we're going to add a 3rd admin, and we're going to use the second admin to vote for the proposal in order for that 3rd admin to be accepted. So let's go ahead and do that. So again, let's go back to the list of commands, and now we're going to add admin3. Keep doing that. Before we do that, however, again, we're going to need the hex address of admin3, not the quantum address. So let's just get the QCLI and get I'm in caps, get a hex address of admin3. And now we can go ahead and paste that command, and like we did before, we're going to replace that replace admin3 hex where it says that, delete all of that, and then get admin3's hex address, copy and paste it into the command, and we're going to go ahead and publish that. And like always, we need to generate one. However, this has not been passed yet. Now we need admin2 to vote for it since we changed the number of votes needed. All right, so like we did with admin1, we are going to need to send some quantum to admin2 in order for him to have the UTXO needed to actually make a contract call. So just send to address admin2. Oh, we just need to send him 1. Like always, we're going to have to generate a block in order for that to be posted. Now admin2 will have that UTXO. Again, if you ever need to check if any of your admins or governance parties have enough UTXO, let me just find it again because it's kind of tedious to write. You can just use this command, list unspent, 1 is the minimum, 99999 is the maximum, and change it to whatever address you're checking. So we're doing admin 2, and he should now have a UTXO. All right, so what we can actually do now is it's going to be the exact same call here for admin 2 to vote for the proposal. Actually, let me just make sure that is correct. It's the same function call with the same values, yes. All right, so what you can do is just go back to your commands that you just did, and here where you made the proposal with admin 1, you just change that call to be from admin 2. What the DGP contract will do is this proposal has already been made, so it's just going to be, okay, this is a vote for the proposal, and it's coming from admin 2, so it's another admin that's voting for it. So that's how the DGP smart contract is interpreting this. So we can just do that. Again, we generate 1. And what we've just done is added the third admin to the DGP smart contract. So now we have 3 admins, but we still only require 2 votes in order to pass any management proposals. So from here on out, anything that we're adding that's management-wise is going to be either admin 1 and another, either admin 2 or admin 3 voting for it. So what we're going to do now is we're going to add the governance parties. And I will explain more about what a governance party has to do with this whole DGP protocol. All right, so let's go ahead and add our first governance party. Just to kind of explain what a governance party has to do with everything, it's just a way to make the whole protocol a little bit more robust. It's a robust voting system where it's not administrators, but other people entrusted in the system to have a say on whether or not a proposal should be passed or not. DGP obviously is being used for consensus values, and more consensus values might be added to DGP later on. As of right now, it's just the 4 that I mentioned at the beginning. But having that ability to add governance parties just make it such that it could be a lot more robust. A governance party is a quantum address, obviously, and it can belong to just an individual, but it could also belong to an organization or a group of people that collaborate in deciding whether or not they want to pass a proposal or not. And obviously, they only have 1 vote, but represent a larger group. So governance parties are just an addition to the DGP to make it a lot more robust. So for now, in our example, we're just going to add 2 governance parties. And later on, we're going to make it such that a value change proposal will require at least 1 vote from a governance party and 2 administrator votes in order for it to pass. So let's go ahead and add that first governance party. So we'll go back to our commands here. And here we have already set the local variable governance 1, and it's going to be the exact same thing as adding the 3rd administrator. Except I keep doing shift, used to the command line. Like we added the 3rd administrator, except that this is just to add a governance party. So let's do that. And I'm just going to do this to make it easier to access again. So let's paste that command. And I completely forgot that we actually need the hex address like we did before. So let's get that hex address. So it's get governance 1. So now we can do that command. And again, where it says replace, we're going to replace with the governance 1 hex. So copy and paste. And again, like I was saying before, so you're sending to the contract we've been sending to this whole time. We're adding an address proposal. This is the function for add address proposal. This is the address we're adding. And this 1 right here means that this is a governance party and not an administrator. So up here you see that there's no 1. That means that this is an administrator that we're adding. Right here it means that we're adding a governance party. And it's admin 1 that is making this proposal, and so it's going to have instantly 1 vote from admin 1. So let's do that. Let me just make sure that my admin 1 still has UTXOs for later. it didn't, so I'm not really sure how that one posted. So let's do that again. Let's just do send to address. Generate one. Make that command again. And now we're going to need a second administrator to vote for it. And I believe in my examples, I have the third admin voting for it just to show that admin 3 has been added. So let's send to admin 3. And now we're going to use this command again and just change this to admin 3. Like I explained before, this is going to be interpreted as a vote by the DGP smart contract. We're voting to add this governance party, and it's going to be admin 3 voting for it. And we're going to generate one. All right. So now that we've done this, effectively what we've done is added a governance party. We voted for it twice, and therefore it's been posted. Now let's go ahead and do the same, but with the second governance governance party that we had. So let's just do this, get hex address. Two. And you know what, I think I still have it in my clipboard. No, I do not. All right. So let's go back here. And here we say we're adding governance too. And we're doing, before we do that actually, let's check that admin 1 still has a UTXO, all right, so now we're just going to replace with the hex address for the governance party, the second governance party. So as we've been doing, and it's right here. All right, and let's check that our admin 2 has a UTXO. Does not. We might as well send him one right now. And we'll generate one in order to post the first vote that the admin did, and as well so that the admin 2 has a UTXO. So let's go back to that command that we just did, change this to admin 2. All right, and we've effectively added well, actually no, we have to generate a block first. All right, now we've effectively added a second governance party. All right, so now our DGP is almost set up for for a quasi-robust environment. So we have 3 administrators, 2 governance parties. So what we're going to do now is use some more management proposals, in this case to require 2 admin votes for a change of value proposal, this being the actual DGP consensus values, and 1 governance party vote. And only then will a proposal pass to change one of the consensus values. In this case, we're doing the minimum gas price. So let's go ahead and do that. All right, so let's go right back to our commands. And yep, so we're going to require 2 admin votes for DGP parameter value add address proposal to be accepted. And this just means that when we want to change that parameter and we make that proposal, there's going to be 2 admins that need to vote for it. So let's get this right here. We're going to be using admin 1 to create that proposal. So again, I just want to make sure that my admin has enough UTXO, and there we go. And I just want to get the base command right there, QCLI, and we paste that that contract call. So we sent to contract, again, the same contract we've been sending to. In this case, this function right here is to change the number of votes required, and we're going to see right here there's a 2, and that's saying we need 2 administrator votes. Here it says, yeah, so that's the value that we're passing, 2 administrator votes and gas values, and it's admin 1 that's sending this, and therefore we'll be enacting that proposal and voting for it at the same time. So let's do that. Let's generate 1 like we have been doing. And now, since this is a management proposal, we're going to need another admin to vote for it. So I just want to check that my admin 2 also still has his UTXO. And it's going to be the exact same call. Let's just change it to admin 2. And now, effectively what we've done is that there's going to be 2 admins that are going to be needed to pass any change of value proposal. So now let's do the same thing, but let's require 1 governance party vote. So let's go back to the commands. 1 governance party. Here you guys saw that I skipped 1. It's because, again, it's the same one. It's just admin 1 and admin 2 that are passing the votes. All right, so this is going to require the 1 governance party. So let's copy that. And again, I just want to make sure that my admin 1 has enough UTXOs. I just do this out of force of habit just in case. And so let's get that base again, the QCLI base command. Paste that command. And same thing, it's almost identical to the one that we did before. Smart contract, same function, except that here we're passing the value for 1 governance party vote. All right, so we're saying we need 1 governance party vote. This is a management proposal, admin 1. All right, let's generate 1. Well, you know what? I don't think I generated 1 from my previous one. Let's just generate 1 just in case. And now we can do the exact same thing again with the 2nd administrator and generate 1. I just want to make sure that I actually did have the UTXO needed for that. Yeah, all right. So now we have set up everything that we need. We have 3 administrators, 2 governance parties, and we've set it up such that whenever we make a change of value proposal, we're going to need 2 administrators to vote for it and 1 governance party to vote for it in order for it to pass. So now we're actually going to make that proposal. We're going to change the minimum gas price. And I'm going to show you how to actually see that happening using your rec test environment. But more importantly, I'm going to show you how to actually make that proposal, which is a little bit confusing if I just did it out of a command because there's bytecode involved. So let's do that now. All right. So to understand what it means to change a value, what the DGP smart contract actually is doing is that the client code is looking to the DGP smart contract to say, has the value changed? If it hasn't, it uses the default value that has been set. And if it has, what the DGP contract is going to be doing is going to be saying essentially, yes, it has changed, and the value, the new value is stored in this smart contract, and it's going to point to a smart contract. So it's not going to be the DGP smart contract itself. It's actually going to point to a separate smart contract whose only purpose is to store that one value. So if we go back to that GitHub that I was showing you earlier that has the actual DGP smart contract, what these DGP smart contracts are pointing to are these less complicated, much more simple value smart contracts. So let's go to the minimum gas price one, which is the one that we're doing. And this is all it is. It doesn't have a change function, doesn't have anything. It's literally a function, I mean a smart contract that stores a value, a single function that gets that value. You can't change that value or anything. So in order to change a value through DGP, you need to create a new smart contract that has that value, so a new main gas price contract template. So essentially you would create another one of these smart contracts with this code, changing the value right here, publishing it, and then making a proposal to say, all right, this smart contract is now holding the new value that we want to use for the chain. So to do that, you need to actually get the bytecode of this smart contract. So a good way to do that, an easy way to do that, I'll show you right now, is if you go to that website I showed you earlier, qmx.blockchainspaceman.com, you can just use that and paste the smart contract here, change the value, so we're going to change it to 80 to be the minimum gas price. That's in Satoshi. And what you can do is go here to the bug icon, choose the smart contract that you want. I only have one in my compiler, so there's only one option here. Click on details, and you can actually get that bytecode that you're going to need right here. So this thing will give you the bytecode. You just copy and paste this whole thing. I already have it here, and I will be I will post it on the article right here, so you guys don't even have to do that. If you want to do it exactly the way that I've been doing it, this is the bytecode you will need right here. But this bytecode translates to this smart contract right here. I'll actually post that smart contract as well. So right here, this smart contract will translate to this bytecode, and this is what you'll need. So you're going to want to copy and paste that bytecode for the next command. So let's go back to our commands. Actually, no, sorry. You're going to want to publish that smart contract, sorry. So yeah, you're going to want to copy this right here. And you're going to go back to your environment. Oops, sorry. And you're going to have to create a contract. If you don't remember, you can always use help, and it'll list out all the commands. And right here, create contract and bytecode. It's super simple. Again, you feel free to play around with this. You can do a lot, but we're going to want to create that contract. So, all right. So create contract, and you're going to paste that bytecode. Generate one. And now if we do list contracts, so here you can see the address of the smart contract that we just published. If you remember earlier, you could only see these smart contracts. These are the DGP smart contracts that are created on Genesis. And as I was kind of saying earlier, these smart contracts are in charge of the client code will look for these DGP smart contracts to essentially ask, has the value changed? If not, it just uses the default value. And if it has changed, the DGP smart contract will be like, yes, here is the smart contract that now holds the new value. So in the case of the min gas price, once we create the proposal and pass it, this smart contract will be the one that holds the value for the new minimum gas price, and the code will use that, and all the following blocks will be using that consensus value moving forward. All right, so now what we're going to do is use this published contract in the proposal to change the value. So let's go ahead and do that. All right, so now that we have that published contract, let's go back to the commands. And here we go. So we're going to do this right here. And again, we're just going to use admin1 to create that proposal and instantly vote for it. So actually, I just want to make sure again, admin1 has a UTXO. You see, sometimes it does that. So let's send to contract. Send to address. Generate one. And now we have the UTXO. And we're going to use that command. So same contract as we have been using before. This is going to be a chain add address proposal. The address we're adding now is a smart contract address. And we're specifying that here, saying this is a smart contract, this is a change of value proposal and not a add administrator or add governance party. So we're going to replace that says replace with contract. We're going to replace it with this address right here. Now that you've done that, press enter. And now if you remember, we're going to need to vote for it with one other administrator and one governance party. So let's check if our admin 2 has a UTXO. No. Let's send it and generate a block. And now we can use the same command as before and just change that to admin 2. Let's generate a block. And now, before we vote for it for the governance, I'm actually going to show you that we are changing the value. So what I want to do is type in help send to contract. Take a look here at gas limit. The gas limit, the default is, I'm sorry, not a gas limit, gas price, because we're changing the minimum gas price. The default is 0.000004 Satoshi, and it's also, Qtum, we have it set to Satoshi in the actual smart contract, and the minimum is still a 4 right here. So that's the default. That's the default and the minimum. So what you should see once we vote for it with the governance party is that this will actually change to 8 because we set it to 80 Satoshi. All right. So now we want to make, our governance has no UTXO, so let's give it some UTXO. Governance 1. And let's generate the block. And let's check that we do. And we have a UTXO. All right, so this is going to be our last call to the smart contract. Let's change this to governance 1. All right, let's generate a block. All right, and now we're going to go to the help send to contract and take a look right here. The minimum has been changed, and the default, since the default was lower than the minimum, it is now the new default as well. And there you go. The minimum gas price is 0.000008 Qtum. And if we go right up here, this was the old one. And notice we've already had 2 admin votes. So this is just to show that everything that we did is actually working. That the DGP smart contract is doing exactly what it's supposed to do. We added the admins, we added the governance parties, but then we added the rules. And the rules were that you needed 2 admin votes and one governance party vote. And here we voted twice with an admin, including making the proposal, and the value had not changed because it still had not followed the rules. Then as soon as we voted with the governance, it changed the value. And now from here, from every block forward, this is the new value, and this is the new consensus value that is being used for the minimum gas price. So there you have it. We've successfully manipulated the consensus value, well, not manipulate, but change the consensus value on our local Qtum chain by using the DGP smart contract that is already published on this testnet. So I hope you like this. I hope you find this really interesting. DGP is really interesting, really cool. It has a lot of potential, and it's super useful in case one of these consensus values, such as even block size. Block size is actually one of the ones that is running right now. If it ever needs to be changed because it is found that a different value will make it more efficient, or it's just a better value to run the chain on, there's no need to do a hard fork. Rather, we can use the DGP protocol. So hope that you find this really useful, or at least very interesting. Feel free to follow along. Again, I will post all the commands required to do this. I will also post all the different hex code for the functions that the DGP smart contract has. So feel free to play around with all the other functions, all the different things you can do. Feel free to change the contract to one of the other ones that's running, to even change the block size. Just have fun with it. So very interesting, and I hope this video helped you have a better grasp about what DGP is, its potential, and how it's used. Thank you.